Hello everyone, welcome back to Cambridge Group. In the last video, we talked about laws of indices and we also did some questions based on the laws of index, laws of indices or laws of exponents. In this video, we are going to talk about a very small topic, which is basically an application of exponent, which is called the standard form. So what is a standard form? So it says that any number is said to be in standard form if it is written in the form of a multiplied by 10 raised to power n. Any number which can be written in the form of some exponent of 10, where that number should lie between 1 and 10. This is first condition, that whatever you are writing the number, multiplying the number with some exponent of 10, that number should lie between 1 and 10, right? Meaning it should not be a double digit number and it should not be negative or in decimals which are less than 1, and the exponent that you are raising 10, that can be an integer, it can be positive or it can be negative. Now what is the use of writing any number in a standard form? There are two uses. One is that in order to represent the quantities which are very large, for example, number of stars in a galaxy, a number of galaxies in universe, right? If you have to, let us say, represent or write the mass of sun, mass of solar system, so all these quantities are very big, which involves a number of zeros, right? If I have to express, let us say, the distance of sun and earth in meters, so that too involves writing a number of zeros, right? So in order to save some space, or in order to keep ourselves restrained from writing that big number, we need to evolve certain way in order to write in a compact form, right? So that shorthand is the standard form, right? So we have this pictorial diagram you can see for standard form, that it describes the mathematical format of a standard form, which is a multiplied by 10 raised to power n, right? And the range of a should be between 1 and 10, as we have spoken, and the integer n, this is an integer, it can be negative or positive. So what are the practical application is the highlights the use of standard form in expressing large and also the small numbers. We talked about just now about the large numbers. Let us talk about the very small numbers, let us say subatomic particles, right? If I have to express, let us say, charge on electron, charge on proton, I think it is 1.6 10 raised to power minus 19, I suppose. So 10 raised to power minus 19 involves 19 zeros after decimal, right? So we have the first digit, non-zero digit after decimal, right? That comes after writing 19 zeros, right? So it is obviously it is not practical to write these 19 zeros, then mention 1 and 6. So again, the shorthand is writing that big or very small numbers, which appears to be small in its magnitude, but it involves 19 to 21 digits, right? So the shorthand is the standard form of writing very big numbers or very small numbers, right? So how we will write these numbers in standard form? Let us do a couple of questions based on this, right? As I mentioned, that these are the standard form examples, right? Distances between sun and earth, size of subatomic particles, speed of light in meters per second, as you have already known that it is 3 into 10 raised to power 8 meters per second. So this form of writing 3 into 10 raised to power 8, it is an example of standard form, right? So let us do some questions on this, that we have to write, for example, following numbers in standard form. As you can see, it involves 6 zeros and there is a decimal point after this last zero. So we can write this number as 0.00, right? Now obviously it involves 6 zeros, so one way of using a shorthand is we can write these 6 zeros as some exponent of 10. So we can write this as 423 into 10 raised to power 6, right? If you go in reverse direction, 423 into 10 raised to power 6 will give you 6 zeros after this 3. So you will get the original number, right? but this is not in the standard form, though you have reduced the size of the number, size of the digits you can say, right? But this is not the standard form, because the condition says that whatever you are multiplying with 10 raised to power some exponent, that number should be less than 10. It should not be equal to 10, and it should be greater than or equal to 1, right? So since this is 423, obviously it is greater than 10, so I need to reduce this to a single digit, meaning 4.23 we need to write this. So in this we have a decimal point after 3 here, 423.00, effectively it is written like this. So we need to bring this decimal point 2 places again towards left, right? So this will be written as 4.23 into 10 raised to power 2. This 2 is for bringing 2 decimal places towards the left from 423, and we have 10 raised to power 6 as it is. So the final answer will be 4.23 into 10 raised to power 8, right? 10 raised to power 2 multiplied by 10 raised to power 6 gives you 8. So effectively, as you can see from the original number, if I show you, this decimal point was after this last 0. So this decimal point effectively has been shifted to 8 places, as you can see from these blue lines, right? So you have shifted this decimal places towards left 8 places. So for that 8 we have the exponent as 8, and please remember that if you shift the decimal point towards left, exponent gets increased. So you can note down key moving decimal point towards left increases the exponent. Okay, so answer is 4.23 into 10 raised to power 8. Let us do second question, which is a smaller number, right? So now here we have a decimal point towards left of some non-zero digits, and 0, how many zeros we have here? 1, 2, 3, 4, 5, 6, 7 and 8 zeros we have after the first non-zero digit, after the decimal point, before the non-zero digit, but after the decimal point. So this time, since we cannot write this as 0 multiplied by something, obviously, so we need to shift this decimal point this time towards right. Shifting towards right, if we are shifting decimal point towards right, exponent becomes negative, right? So we have to move this decimal point such that it appears at after 2 but before 3. Remember, if we write this as 23.4 into 10 raised to power something, that 23 is again greater than 10. That should be kept between 1 and 10. Remember the condition on A. So let us count the decimals. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So effectively we have to move this decimal point 9 places towards right. Right, so I will write this as 2.34. This decimal point has been shifted 9 places. It becomes 2.34, and since it has shifted 9 places towards right, so I need to write this with a negative exponent. Okay, so moving a decimal point towards right, the exponent will decrease by 1, right? So you can note down this again, but for moving towards right, that moving decimal point towards right decreases the exponent by 1. Okay, this is also by 1. By 1 means 1 place, so one number will be increase or decrease respectively. Fine. So the answer will be 2.34 into 10 raised to power minus 9. Let us do one more example. It says we have to work out the following and give the final answer again in standard form. Now, as you can see, we have two numbers which are given in the standard form, right? We have 4 into 10 raised to the power something, again 5 into 10 to the something, and we need to multiply these two. So the first step would be that since I can see that 10 raised to the power minus 5 and 10 raised to the power minus 6, we have same bases are in multiplication, so we can add their exponents, right? So we can multiply the 10's exponent separately and these numbers 4 and 5 separately. So solution is that I can write this as 4 into 5 and then multiply this 10 raised to the power minus 5 and 10 raised to the power minus 6. Same base, exponent gets added, and I multiply this 4 with 5 as 20. I get 10 raised to the power minus 11. This is not again the standard form. It appears to be in a standard form, but here again this 20 is greater than 10, right? We need to keep this, I'm emphasizing this again and again, that we need to keep this 20 between 1 and 10. So I need to bring this decimal point towards left one more time, right? And if I move towards left, exponent increases by 1. So 2 into 10 raised to the power minus 11 was the original exponent. It will be increased by 1, so plus 1. The final answer will be 2 into 10 raised to the power minus 10. Okay, it appears that the exponent from minus 11 has been reduced to 10. Okay, but this exponent is in negative, so effectively minus 10 is greater than minus 11. Okay, so I think there is no need to do some more questions as far as standard form is concerned. This is, I think, enough in order to make the concepts clear, how to write big number, small number, or some combination of numbers in the standard form. Okay, thank you.